Many people in business think that an AI system means just a simple large language model and a prompt. But that's not true. And in fact, that sort of thinking is why most AI systems fail. Real AI systems have a serious structure. Hi, my name is Joshua Ebner. I've spent 20 years in the AI and data science industry, including time at Apple, Bank of America, and boutique consulting firms. So in this video, I'm going to show you a high-level architecture that most AI systems follow. I'll show you the common components, what they do, and how they fit together in order to produce reliable systems that solve business problems. Okay, first, let's just take a look at the high-level diagram. So this is a high-level architecture that most AI systems follow. Not every AI system uses the exact same architecture. There are going to be differences and deviations, but this is a pretty good starting point for most AI systems. You'll see that we can read it mostly from left to right, but there are some other things towards the top and the bottom that kind of get integrated into the workflow. We'll cover all of that. That said, let's jump into the details. First, on the far left, we have the user/task. Now, in many cases, this is going to be a human user that's providing a query or a specific task or a prompt. But in some cases, the user is going to be some other system, some other technology system in the business. So don't necessarily take this too literally that it's a human user. It might be another system. Next from there, if we go one step to the right, we find the query itself or the task. So typically we have a query that's being inputted into an AI system. So this is something like a user prompt or a user message. There are other types of prompts in AI systems. There are things called system prompts. We're not going to get into all of those details here in this architecture, but I do want to kind of point that out. So the query usually embeds more details about the specifics of the task. Queries can get quite long and detailed depending on the exact nature of the task. There are also, by the way, best practices around query construction, prompt construction, prompt engineering, and so on. I'm not going to get into those details here, but I will say that it is a very important part of a solid AI system is having well-engineered prompts, both from your users, but also some of the processing of those prompts as they enter the system. Next, we have input guardrails. Input guardrails are usually more of a security or control feature. We're just trying to catch things that shouldn't be entering the system from the query or from the prompt. So if there's some sort of malicious prompt or some sort of prompt injection, if there's a request in the prompt or query that the system shouldn't answer, things that are inappropriate, and so on, we're typically trying to catch those things early on. So these input guardrails are more of a security feature, just trying to catch things that shouldn't be entering the system and shouldn't be processed any further. We'll also see another set of guardrails, the output guardrails, later on. By the way, if you want to use AI in your business, take our AI transformation assessment. You can find the link in the description below. It's about 15 questions. It'll take you less than 5 minutes, and it'll help you diagnose what you're doing right and what you're doing wrong in your business so you can transform how you are operating using AI. Find the link in the description below and take our AI transformation assessment right now. Next, we have the real heart of the system, and this is the orchestrator. Now, there's a couple of different components, and the specific details here really do depend on the specific system that you're building. So this is sort of a high-level, abstracted overview, and the details of your system might change. But here what we have is several different components that can be inside of an orchestrator. Sometimes we have some deterministic logic that will process an incoming query or a request. That might be, if you're coding in Python, that might just be some deterministic Python code or Python logic that is going to accept a request, route things in the right way, and so on. That can also include a large language model. Large language models, and particularly reasoning models, can examine incoming requests and figure out how best to handle a request, how to process things, and so on. Furthermore, it might be some agentic logic where there is some reasoning, some processing, then looking at the output of the initial processing steps and then making another plan or making additional steps of a plan, doing more processing and so on. All of this with some potential reasoning and planning that goes on. Like I said, every system is a little bit different. Sometimes this is going to look more like a deterministic Python script. Sometimes it will look like an LLM that's just processing and parsing incoming prompts. Sometimes it will look more like agentic processing where there is planning and reasoning and multiple steps. So keep that in mind once again that this orchestration step can vary a lot depending on the specific problem that you're solving and the nature of the task. Next, if you look at the box just above the orchestration system, you'll see tools and external systems. So here I'm talking about tools that are made available to the central AI or the centralized AI agent inside of the orchestrator. And those tools can be used to process incoming data, process inputs, process the prompt, the query, and perform the task. So this can include things like additional programs, additional scripts like additional Python scripts. It can include additional applications. So for example, a calendar, if you need a system to be able to do some scheduling or planning. This might be search. In many cases, agents and AI systems need to search the internet, pull some information from the internet. That might also mean searching through an internal information source. In certain types of advanced cases, this might include sensors and sensor data. I think this is going to become much more important as we start integrating AI with things like the Internet of Things and robotics. There are certainly physical systems that can be integrated with AI processing systems, and that sensor data is where a lot of that information is going to come from to do that integration. There's a variety of other types of tools. There's also, by the way, there's other AI and machine learning systems. In many cases, I think that lots of AI agents and large language model driven systems, in many cases, they benefit from having access to other types of AI and machine learning. So, for example, if you are building some sort of marketing agent, it could be a good idea to have access to something like a churn predictive model or a upsell model, a cross-sell model. And those sorts of models are often built with more classic machine learning tools as opposed to large language models. So incorporating those machine learning systems will probably mean turning them into tools that can be used by the centralized orchestrator or the centralized AI processing system, the centralized agent. Ultimately, though, these tools give your AI system more functionality and more ability to solve problems and complete tasks. Now, from there, if you look below the orchestration system, you'll see something different. This is memory and context. Now, many AI systems need memory in order to perform well. You might have heard of something called hallucination, where AI systems just start making up facts and details. One way of preventing that is giving them access to current data sources in the form of traditional relational databases or vector databases. We would consider both of those things to be more of a form of long-term memory where there's some sort of long-term storage of information. There's also various types of short-term memory. I don't want to get into this rabbit hole of different types of memory and how they all differ. But the context window itself of an AI system and the thread, the processing history of the AI system, that in and of itself can also serve as a form of short-term memory. Ultimately here, though, we're trying to maintain relevant informational resources that the AI system is going to need to perform well. Now, using some of the tools, using the information stored in short-term memory and long-term memory, the orchestration system is going to process information, process the incoming query, process that alongside potentially some additional data resources, using those tools, process that information into an output. Those outputs can be actions, it can be text or a document or something else. But before we actually produce that in a final state, there's a guardrail step. So previously, I talked to you about input guardrails, stopping bad queries or prompts from entering the system. We also want to stop things from leaving the system that shouldn't be produced as output or shouldn't be given to a user. This can include toxic outputs. It can include factually incorrect outputs. There are some ways of checking and validating outputs I'm really not going to talk about here, but there are various types of engineering patterns that you can use to validate the output. But if the system does find an incorrect output, something that's factually wrong or toxic, or potentially something that's sensitive, some sensitive data that shouldn't be shared for security reasons, the output guardrails are supposed to catch that information and stop it from being shared. Assuming that the output passes that output guardrail step, then we move on to the actual output of the system. Now, that can include things like actions, processing steps, text output, reasoning, documents, and so on. Remember, this is sort of a high level architecture that applies to a variety of different systems. So, the exact types of outputs are going to depend on the nature of your system, the nature of the task that it's solving. But this is the step where it produces outputs. Now notice that there is also a dotted line that goes back to the user. Sometimes an AI system produces an output and it's delivering a document somewhere, putting a document into a folder, changing a document somewhere. But in many cases, it's also sending information back to the original user. Again, this can differ by system, but you're probably familiar with this when you ask an AI system like ChatGPT a question. It's actually going through a lot of these processing steps behind the scenes, and then it sends that information back to you as an output, text output. There's one other thing that I want to point out. Notice in many of these boxes, there's a little icon that says Evals. You might have to look closely, but it's there. And you see this in the orchestration layer. You see this in the tool layer. You see this in the memory and context engineering layer. You also see it at the output step. And what I'm trying to communicate here is that we usually have evals at a variety of different places inside of the system. Now, again, I will reinforce that this can change depending on your exact system, your exact architecture. But in many cases, we have different evaluation steps, checking that things are working, checking that system performance is being maintained, monitoring metrics. This can include things like evaluation data sets. It can include things like traces that are going to track the latency of every step and things like that. You can use tools, for example, like Langsmith for this. I'm not going to get too far into the weeds on traces and things like that, but if you are trying to build a system and reduce your latency, you often need these sorts of evaluation tools. So I want to reinforce a couple of things here. Number one, if you want to build robust systems that perform well consistently in production, you need to think very carefully about evals, and you often need to have evals in a variety of different places inside of your system. So at a high level, what I want you to understand is that an AI system is a lot more than an AI model or a large language model plus a prompt or plus a little bit of incoming data. A really good, robust AI system is going to need input guardrails, output guardrails, context engineering via long-term memory systems and short-term memory systems, vector databases, traditional databases, and so on, tool use, potentially quite a bit of internal logic, orchestration, reasoning, and then evals sort of end to end. And all of that requires AI engineering. But even if you're engineering great systems that perform well for specific tasks, if you want to get serious business value from AI, you're going to need to think carefully about AI integration. So that's why you should watch this next video on the 4 levels of business AI integration. You can check it out here.